Okay, I'm going to show you guys how to do the 8 ray diagrams for physics. First, we're going to go over concave mirrors, and then we'll talk about a convex mirror, and then we'll do convex lenses and a concave lens. In each of these, you'll need to know how to draw the diagram, and then you'll also need to know if it's real or virtual, upright or inverted, if the magnification is greater than 1, if the magnification is less than 1, or if the magnification is equal to 1. So let's start with a concave mirror object outside the focal. Now these drawings are in general. We're not given a specific location for the focal or for the object, so we're free to choose as long as it meets the requirement. For this one, it's a concave mirror object outside the focal. So I'm going to draw my line. This is the principal axis. I'm going to put my mirror right here. And I call this a concave mirror, so I label it this way. That way I don't have the curve. It makes it easier to draw the ray diagram. I'm going to put my focus here, and I'm going to put my object here. And about that high. Okay? I could put it here, I could put it out here. It doesn't matter as long as it's outside the focal. And I'm free to put the focal anywhere on this side, of course, because of the curve. The lens is curved, the mirror is curved this way, so I can put the focal anywhere on this side, but I'm free to choose that just as long as I have my object on the outside. So this is a general ray diagram for a concave mirror object outside the focal. First thing you do is parallel to the mirror from the object. Where it touches the mirror, it will leave through the focal. And then from the object, I draw the light ray that goes from the object through the focal to the mirror. And then where it touches the mirror, we will leave parallel. And then where the two lines intersect is our image. So from here to there, and this one is pointed that way. So this one is a real image. It is inverted, and it looks like, the way I have it drawn here, that the magnification is greater than 1. Now, of course, if I move this object over here and I draw this, then I might get an image where in this area here, and then the magnification would be less than 1. So this right here can change depending on how you draw it. But you need to label what you have drawn. So don't try and memorize a concave mirror object outside the focal and say it's real, inverted, and greater than 1. Because if you draw this too far out this way, your ray diagram will have a real inverted image that's less than 1. Okay? So this was concave mirror object outside focal. Okay, let's try concave mirror object inside the focal. Draw my principal axis, draw my mirror, label it as concave. I'm going to pick my focal out this way. Notice it's a little bit farther than what I picked on the last one. That way I can move inside and do a little bit better, my object inside, have a little bit more room. So I'm going to put my object, say about right here, about this tall. And we do parallel. And this will go through from where it touches the mirror through the focal. Remember that a concave mirror is a converging mirror. And then I line it up with the focal, and I draw from the object to the mirror, but I line it up with the focal. And then where it touches the mirror, it will reflect parallel. When we say parallel, we're talking about parallel to the principal axis. If we notice this doesn't cross, the real ray diagrams do not cross, so then we need to extend out to the imaginary rays. And then I'm going to continue this one out. And I know this because I've drawn several of these, and I can see that just visualizing these different rays extended out into the virtual part, I seen that these were the only two that were going to cross. There is also an imaginary light or imaginary ray from here parallel out this way, and there's a dotted one that goes out this way, and there's a dotted one that comes down this way. But I don't need those to create the image for this one, so I won't draw those. If you do draw out the imaginary ones and they don't cross, then just keep picking imaginary ones until you find the two that cross. So in this case, here's my image. And I see that this is upright. It's virtual. The reason it's virtual is because one or more of the light rays that create the image is dotted, and we see that it's greater than 1, because the magnification is greater than 1. This was concave mirror, object inside, focal. Next we'll do concave mirror, object at 2F. So this is a special case. In this one we actually do have to measure. So I'm going to draw a 10 centimeter long line, principal axis here. And I don't want to move my head in front of the lens here, in front of the camera, so I'm going to, it might be off a little bit if you're looking straight down. I'm looking at it from just a little bit of an angle, but this is close enough. And I'm going to put, I'm going to go ahead and put my mirror about right here, and I want my focal length to be 2 centimeters, so that'll be here, and then 2F would be here. So this is 2 centimeters from my mirror to my focal, and then 2 centimeters from my focal to where my object will be. So here's my mirror. We'll find out how close I am. And I'm going to make my object here. And this is a concave mirror, so I label it. I'm going to go parallel, focal, and then line it up at the focal from the object through the focal towards the mirror, and then where it touches the mirror I leave parallel, and looks like I did a pretty good job. The object or the image is at the same position as the object, just inverted, and the magnification should be equal to 1, and it looks like it is. We can try and measure. Looks like approximately 1 centimeter for both the height of the object and the height of the image. So this is a real image. It's inverted, and magnification equals 1. This is the special case of a concave mirror. Okay. Last for the mirrors is a convex mirror. Convex mirror is a divergent mirror. So I'm going to draw my principal axis. Notice that I don't have a object inside the focal, object outside the focal, because on a convex mirror, the curvature is this way, and so the focal is on this side, but my object is on this side. So I'm going to go here, and we go parallel, focal, and I line up with this focal, and I draw away from the mirror because it's divergent, so it bends or it reflects the light back this way. So that's parallel, focal. Now I need to line it up with the focal. and from the object to the mirror, and then where I touch the mirror, I reflect parallel. Okay? And then, of course, we see that these do not cross, so I need to do the imaginary part. I'll do it this way so I can see a little bit better. And if I extend this one out, imaginary, I see that these cross here, so this is my image. It's a virtual image, it's upright, and M is less than 1. Okay, this was a convex mirror. Okay, so now we're going to talk about lenses. And lenses are kind of the inverse of the mirrors. So we have 3 convex lenses, object outside, object inside, and object at 2F. And then we also have a concave lens, which is kind of the opposite of what the mirrors are. And one thing to note about the lenses is that light goes through the lens. So instead of hitting a mirror and reflecting, the light is going through and refracting, so it's bending as it goes through. So I draw my principal axis. I put my lens at about the middle. This is a convex lens, so that means it's bowed out in the middle. And so I label that this way. This kind of represents the curvature from this side and the curvature for this side. And unlike a mirror, the lenses have 2 focal points. We have a focal point that would create this curve on this side, and I have a focal point on this side that creates this curve. And I try to make those about the same, so we have a symmetric, and I should probably measure these from here on out. Looks like it's off a little bit. And we want to draw a convex lens with the object outside the focal. So I'm going to put my object about right here. And we do parallel, just like with mirrors. And then focal. So now I have a choice to make. Do I line it up with this focal, or do I line it up with this focal? And do I go this way, or do I go this way? Well, we said that light goes through the lens. And we know that convex lenses are converging lenses. So that means that it's going to bend towards the principal axis, and it goes through. So I have to line it up with this focal down this way. So from where it touches the lens through that focal. So parallel, focal, now focal, so I line it up with the object, and I go through this focal towards the lens, and then where it hits the lens, I refract through parallel. This way is a little bit better. And then where those 2 lines cross, that is my image. So this is a real inverted, and this one's a little hard to tell. I think that the magnification is greater than 1. If you said equal to 1, you'd probably be okay. You can definitely tell it's not less than 1, but it looks like it's a little bit bigger. So if I move this object closer to the focal, we can see that this angle, this line here, is going to get steeper, and it's going to come down here, which will come out this way, which will give us a larger object. So as we move closer to the focal, the image of the object will be getting larger, and as I move away from the focal, this angle here is getting shallower, so the height of the image will be getting smaller. Now if you notice, this line will always stay the same, this ray that goes in here and bends down. So really we're getting images along this like cone or triangle part that we're looking at. So as this line moves down, we get this image, and then this image, and then this image, and that image. So if you kind of want to think about what's happening as you move, that's what's going on. Now there's a lot of websites that you can Google and find where they have flash and different interactive media that you can actually decide what kind of lens you want, where you want the focal, and put an object on there, and you can move the object around and it'll show you the image in real time. Very useful tools. So if you want to go just a little bit further than just drawing array diagrams and really understand what's happening, you should try one of those websites. Okay, so this was Convex Lens, object, outside, focal. Now we're going to do convex lens, object inside the focal. And I'll try and get my focals a little bit better here. So I'll put my lens here, and I'll put my focals at 3 centimeters away from that. So there's my lens. Convex. My object is inside. So I do parallel. The light goes through the lens, so I need to line it up with this focal, because it's a converging lens, so it's going to bend down towards the principal axis. And then I line it up with the focal going towards the lens, so that's from the top of the object to the lens, and then it's going to go through the lens parallel. And if we see these lines do not cross, so I'm going to extend out to imaginary. I can definitely see that these two lines going out this way will cross, so I'm going to do those as dotted, imaginary back this way, and extend this one. And I have an image right here. So this is virtual, upright, and magnification is greater than 1. Convex lens, object inside, focal. Now we'll do the special case, convex lens object at the 2F. So I definitely have to measure this one. And let's do, well, it's about 12, so exactly in the center will be 6. I'm going to go 2 away, on each 2 centimeters away from the center, from the lens, to make my focal, and then double the focal will be 4 away, or 2 away from the focal. So here's my lens. It's convex, so I'll label that. These are my focal. This is my object. Let's see if I can do, if I measure correctly and if I can draw parallel lines. Parallel, converging lens, so it goes through the lens, through the focal. Line this one up with the focal towards the lens, and where it touches the lens it'll go through parallel. And then here is my image. Okay, so if we try to measure this, it looks like about 1.3 centimeters. And over here we have, about 1.3 centimeters. And our distance away is 4 for the object, which is what I had originally measured. And it looks like I'm off by just a little bit. I'm a little bit past 4 centimeters. But it has to do with where the focals are, if you can draw a parallel line, and how well you line it up. If we notice, I didn't go quite through the focal right there, but still pretty close. So this is a real image. It's inverted, and magnification equals 1. convex lens, object at 2F. Okay, so all these have been parallel, focal, focal, parallel. Now we're going to do concave lens. This is a diverging lens, so this is the only one that's different. And what we'll do with this one is we're going to do parallel, focal, center. Now we could still do parallel, focal, focal, parallel, and it'll work out, but there's a lot of more lines involved, and it gets a little crowded where the image is at. And so I think it's a little bit better if we do this with parallel, focal, and center. So this one is labeled this way to show the curvature going here, and the curvature on this side. That would be a concave lens, would look like that. My focal, I have two focals. The one on this side is for this curve. So we'll put that at 3 centimeters from the center, from the lens. And then over on this side, I'll go 3 from the lens. This one is for this curve, this one is for this curve. And I'm going to put my object inside the focal for this one. We do parallel and then focal. So a lot of mistakes is we'll line it up with this focal here and I'll draw it down, but this is not a convex lens, this is a concave lens, so it's a diverging lens. So that means that the ray that goes through needs to refract and bend away from the principal axis. So we actually line it up with this focal and we draw it out this way. So parallel, focal, and then center. So we line it up with the top of the object and go through the center where the principal axis and the lens meets. You can think of this also as the origin if it was a XY coordinate system. So if it's a Cartesian coordinate system, it would go through the origin. And we don't cross out here, so that means we need to have the imaginary line. So I'm going to extend this one back this way in the imaginary, so dotted, and here's my image. So this is a real image, or a virtual image, because at least one of the lines is dotted. It's upright, and magnification is less than 1, the way that we have drawn it here. Convex or concave lens. In this particular case, the object is inside the focal. So you guys should try and do one where the object is outside the focal and see where your image is at. Okay, if you have any questions, just see me in class. Thank you.